So I'm a developer relations advocate with a company called FlowFuse. Anyone who's familiar with Node-RED industrial sort of automation, you'll be familiar with FlowFuse. I also am a YouTuber. Yes, late 30s YouTuber. It's very sad. But tech-fluencer, I guess. I've been a Nordic APIs author for a very long time. Feels like a lifetime at this point. I'm also an advisor with a company called Developer First, which does a whole bunch of like boutique product marketing. And at this point, I've authored something like 750 articles, books, all kinds of stuff. So that's sort of my professional background. To give you a little bit of insight into why this topic particularly is of interest to me, I do a lot of international advocacy. And that advocacy is in sort of typical North America, a lot of European advocacy, obviously because I'm here, and then also a lot of Asian advocacy, so Japan, South Korea, China. And that's going to be really important in just a minute. So this is like the understatement of the century, right? I think we're all aware at this point that the international order is changing. But it's not just changing in like really obvious ways. So obviously there's the US portion of this, which is complex, but there's a little bit more. So I'm going to give you a couple graphs. I'll explain them, but I really do think that if this interests you at all, go to the link, look at all the graphs. A couple things here. So this first graph is the number of AI patents that have been granted worldwide. You'll see that it just sort of like rockets up. And then the training data set size of those notable models and what that actually looks like. And you'll see again, as we trend over time, models are getting more complicated, and thereby the data required for those models are themselves becoming larger and larger. You also note this is an interesting picture. This is the number of notable AI models by geographic area, and then mapped over time. Now, it does look like we have a steep decline, but you need to contextualize this with the fact that we have a lot of basically models that are collapsing to a single model. So where you used to have one provider that had 50 models, now you have a mega model that is the model of all models. Hasn't actually changed the game, but it has changed the numbers. Okay, so what this looks like and why this matters for us, when you look at the amount of available data on the internet for training these models, we're running into what I call an epistemological horizon. That is a very nerdy thing, so hear me out on this. An epistemological horizon is basically when you have reached a state where what you can know runs into a wall. You can't know more because the context of that knowing, the context of your education has hit that barrier. We're now getting to the point where the extrinsic data that we have on the internet, the extrinsic data that is documented, so things like GitHub repos, Facebook posts, those sort of things, we're reaching a horizon where everyone has that data. Every single person. And even though we have this world population who's constantly adding more data, that data is not significantly differentiated from any of the other data. Your grandma on Facebook, a Swedish grandma on Facebook, American grandma on Facebook, Japanese grandma on Facebook, they all have like different things they complain about, but they're all pretty much the same, which is why we ignore that kind of stuff. And so for AI training, that's not actually anything that's super helpful. So what this has resulted in for data sovereignty is this real interesting, it's almost like a rubber band being pulled in two different directions. We have two different groups that are interested in very conflicting things. On one side, we have AI providers. We have these sort of neural net providers, machine learning providers, however you want to call them. And they want a whole range of things. They want diverse data types. They want things that are easily categorized. They want royalty-free data. As we've seen, I'll reference in a minute, some providers don't care about royalty-free. They just download and do it anyways. And so that's sort of like one side of the tension. On the other side of the tension, we have sovereign data regulation, which is itself a massive a stressor on this. So categorized data is a good example. If you have a country like France who says, no, we actually value the privacy of our citizens, you can't have that data, it's very, very structured. That's a gold mine for these providers, but you can't have it. It's not yours. Stop trying to get it. And so you have this huge, complex problem. And I'll give you just sort of a snapshot of what this looks like in practice. So let's say you have, and this is broad-based, I'm using countries here, but imagine any locale. Imagine you have France, Japan, and China, right? And you have interoperable data privacy, data sovereignty regulations, but they're not all interoperable. Excuse me one second. And so if you have French data, if the French are going to the Japanese, they're saying, hey, we want more affordable data. Japan's saying, well, we need strong markets, so we want adequate pricing for that data. In the inverse, Japan is saying, hey, we want new market access. And France is saying, well, you can come into some markets, but we're not going to let you into other ones. And so they come up with this mutual adequacy. That's a real hard word to say. Mutual adequacy, which is basically, yeah, our data sovereignty and privacy regulations, they match in some way, so we'll agree to work in this way. Where it becomes more complicated is when you have something like France and China. Now, China has data privacy and data sovereignty regulations, but they are very different from Western conceptions of that. As a good example, France may want portable data, whereas China wants it extremely localized. They don't want data to ever leave China. They're fine with other data coming in, they don't want Chinese data to go out. For the French, it's sort of the same, but a little bit different. The French data privacy regulation, they want independent supervisors of that data set. They want someone who's independent of the process to come in and say, yes, this has been protected, or yes, this is this, this is this. China will only let China own China, point blank, whether it's data, government, whatever. And so that's completely incompatible. And so what has risen out of this, I'm not going to go through all of these. This is a snapshot of some of the frameworks that we have for sovereignty and privacy. And I would say we're at the state now where maybe 70 to 60% of them are interoperable, and the rest either don't exist or they're completely incompatible. So what does this mean for technical implications of this? There's a couple things. There's different systems and approaches that have risen in this landscape. There's a couple ones like data localization. Obviously, data is stored where it is. But then you start getting into a little bit more complex implementations. And so I actually want to show you a couple of those implementations now and talk about what we need in the future to make sure that this is something that we as practitioners and providers can actually give people to move forward. So the first one I want to show you is called federated learning. And I've put sort of like pithy summaries for all of these. I would say this is trust the protocol. And the idea here is that data resides in X, the model trains in X, and then the weights can train it to Y, okay? So the French have their model, they train their data. They then send this model, the model itself with the weights all packaged out. They can send that to any other locale. And because everything has happened in terms of the data training itself has happened sovereignly in France, then the models and the insights that are generated from that, although that is protected data, it's not the same sort of weight that comes with the actual models versus the data piece of it. And so they're fine sending the models out. And then you can train additional weights, additional data, and it all gets collected. And it's federation. We're familiar with that. There's a little bit more complex flow here, which is sovereign cloud and residency. And I say complex not in the technical term, but in the socio-political term. When you have France who says, hey, this is French data, we've collected data not just from France, but around the world, we've trained this thing, and now anybody who wants to use it, make an API call. You're not getting the weights, you're not getting the model. That sounds equitable. But if you're a user in something like Vietnam, who has a long history of colonial issues, and someone is saying, you can get your data in our model, but we're not going to let you actually access anything, send an API call. That itself becomes problematic. And it's a whole other sort of consideration. It becomes challenging, okay? What I think is probably the most interesting technical implication here, or integration, is something called homomorphic encryption, okay? Now, the reason I've sort of rushed through this up to this point is because this is by far like the most complicated piece of this. What homomorphic encryption basically is, for anyone who's not familiar, you encrypt a data set in such a way that the actions you take upon that data set render the exact same responses as if you acted on the data set itself, okay? Let me put that a different way. If you have everybody in this room, okay, all of your personal data, your birth date, your locales, everything, all of that data is really personal to you, it's private. You don't want someone coming in and saying, okay, I'm going to run a test on this room. How many of you take antidepressants and what are your age and where are you from? But if we collect all of that data and then encrypt it and then provide that encrypted data outwards with homomorphic encryption, someone can act upon that data and get those insights back without ever knowing the actual underlying data that constructs that data set. Okay? If you're an Apple user, I'm an Apple user, homomorphic encryption is actually used pretty widely through Apple products. And there's a couple other providers who are starting to adopt this. Where it comes into a little bit more complexity for model systems is that in one hand it resolves some of the issues in terms of technicality, right? If we want access to Chinese data, if we want access to French data or Brazilian data, great, you now have this encrypted access. But let me ask this question. If you are a political leader and you send an encrypted version of your data to somebody else, and then they send that data back to you. There's two things there. One, how do you trust the data? How do you trust that they didn't do something to that in transit? We can say it's encrypted now, but like quantum computers are becoming a thing. And so how do you validate that that is actually what you're getting back? That's part one. Part two is something where in this flow, Francis said, hey, we're going to interact with French data. Send us your encrypted data. We'll do all the work of working on that data. And then we'll send it back to China, and then China will send us the new updated model, or the new updated weights, rather. What happens if China says, no, we're not going to do that? What happens when you've spent millions of dollars training a model and working on your own resources, and who has provided the encrypted data says, actually, no, it's fine. Don't worry about it. What does that mean? Is that an act of war? Is that corporate espionage? Like, what even is that? And so, looking into the future, all of these systems, there's a couple things I really want to highlight here. And it's not me drinking on microphone, sorry about that. So there's three things. The first one is, this all feels kind of like microservices, right? Like this whole movement reminds me a lot of the story of like the monolith to microservices. We're getting away from this idea of, okay, one model, one data set. Okay, well, no, we're not really doing that anymore. If you use like ONNX, this idea of like an open format for your neural nets, an open format for connecting to data, we're moving away from that idea that like Meta's data set is Meta's data set, now it's everybody's. So that comes with a lot of things. It comes with decentralized services, but more than anything, it comes with the understanding that we're abstracting the model away, and that comes with a lot of caveats. In the same way that like microservices, when we first talked about it, was, oh, this is so fast, it's so great, it's so efficient. Yeah, but you're also spinning up thousands of nodes for like what should be a pretty simple thing. Like that's, so there's some caveats there. The second one here is controlling data access. The reality is that data access is going to happen whether we want it to or not. We saw that with Meta, for example. Pirated content used to train their model. That happened. So we need to get ahead of that. And then this last piece is the sociopolitical issues. We need to stop talking about data as if it's just this ephemeral thing. This is not MySpace profiles anymore. The way that we treat oil, the way that we treat gas or natural rare earth metals or minerals, we need to be treating our national data the same way. And that comes with a few things. This here, to give you an example of what this looks like in my brain, full disclosure, like I said, DevRel at FlowFuse. I'm going to obviously say FlowFuse, I think edge orchestration is going to be a big piece of this, and I think it has to be for a couple reasons. One, we need to get ahead of the complexity that the system is going to introduce. Because just like microservices, that movement of, yes, the monolith is one code base, it can break, it can do all these things. But when you have a problem, you know where it is, because it's only one thing it could be, right? It's that horrible spaghetti monster we created. When it's a microservice, it's a little bit more difficult. And in the same way, we need to start talking about, okay, when we have multiple homomorphic encrypted streams, when we have multiple models that are sending the same weights, when we have conflicting weights, when we have conflicting models, how do we actually fix that? How do we find out where these models are coming from? How do we find out what has gone into this problem? And so I put together sort of an extremely dense slide. I apologize for this. There's really three categories that I think we urgently need to figure out. I was just telling someone off stage that in 2016 I had made some public declarations at an API summit that like, hey, we need to take nation state hacking seriously. And the feeling was like, oh, that may be like, that's like a, technomancer thing. And then our election was hacked. This is no longer a problem that is maybe 20 years down the road. This is a problem that's like 20 days down the road, 6 weeks down the road. So the first thing we need to avoid, protectionism, isolation, neocolonialism. We need to stop thinking about data as just this ephemeral thing like everyone's on Facebook, cool. We need to get out of this reality where right now it's totally possible that, say, Africa medical data could be exfiltrated from Africa, used to train in pharma companies, and then used only for treatments that are available in Europe or available at an exorbitant price. That is the reality we have right now. That can't happen, okay? We need to stop reacting too slow, and as part of that, we need to stop considering data in this sort of like way. It's an actual resource. It's something that is serious. We need to get away from this compliance theater, which is like the promise of data is so exciting. You can go to ChatGPT and do this thing. Yes, but it's also using an exorbitant amount of resources. It's highlighting how insecure our data systems are, and we have not figured out even the beginning of how to resolve this problem. So we need to really accelerate. In terms of what we need to figure out for urgent problems, in the next year or two, and it really is that quick, we need to figure out things like leakage paths. We need to make sure that there's no sort of like, okay, this data we sent over, we think it's secure, but like how can you reliably prove that a data set that is passed through k-anonymity can't then be tracked with other data sets to identify the people within the data set? That needs to be figured out very quickly, especially for sovereignty issues, because you can send data out from a GDPR compliant country, and then go to a non-GDPR compliant country. Can you actually validate that it has still stayed compliant? Attestation standards and mechanisms and key management is going to be a big part of this, but there's also issues of rights to decrypt. What does that mean when, like I said, a country refuses to provide the actual data from your originator state? And then there's compliance claim attestation, which is kind of what I was pointing out a few minutes ago. How do you actually know that data from the EU didn't leave the EU? Okay. In terms of long-term compliance, this is going to be the heaviest one. We need, as practitioners and as people who influence this industry, we need to be advocating for international governance, point blank, on AI, large language models, everything. Some of the loudest voices in this industry for AI have said that like this is like Oppenheimer level. We need to like react, okay? We need multinational agreements on privacy. We really need to figure this out. The States is way, way behind. Just point blank, the US is behind. Canada less so, but still behind. We need to figure out encrypted compute. That's going to be the next stage of this, which is things like trusted execution environment, multi-party computation, fully homomorphic encryption as a standard on all devices. And we need to figure out machine policy negotiation and alignment. This is like that XKCD comic where, oh, there were 9,000 standards, now there's one more, and now there's 9,001 standards. We need to figure out this piece, because if just one country does their own thing, the whole system falls apart. So what I'm advocating here, and this is sort of the summation of this whole point, this is no longer a 6-month problem, a 6-year problem, a 10-year problem. This is not like fusion, where we've been saying it's 20 years away since the 60s or 70s. We're now at the point where this is happening now. This is an issue now. And we are lucky because we have spent so much time on this issue generally that we can advocate between ourselves. We need to figure out a way to make everything that I just said accessible to the average person, and that they can actually walk away from it in the same way that they walked away from Cambridge Analytica and said, oh my God, that's a problem. And so that's the challenge that I want to give to you all. Like I said, the link's at the top. Go read the dense nonsense here, and I'll be updating this over time with additional links and context. So that's me.
Thank you, Kristopher. Awesome.